Hello people, good to see you again. So today we will be practicing some questions on the topic thermodynamics. Every year one or two questions in exams are based on this chapter. So without wasting time, let's jump to question number 1. Now question number 1 states that a fixed mass of gas is first heated isobarically to double the volume and then cooled isochorically to decrease the temperature back to the initial value. By what factor would the work done by the gas has decreased had the process been what? Isothermal, that is the temperature is constant. Now let the initial pressure and the volume be P and V respectively. Then after isobaric expansion they are P2 and V2, right? Hence the work done, that is after the expansion the P is going to be P only and the volume is going to be 2V. So therefore the work done, that is P delta V, is going to be nothing but P times 2V minus V, that is nothing but what? PV. Correct? Then to bring to initial temperature new pressure, we know that PV upon 2V equals to nothing but P by 2. So after isochoric process, they are P by 2 and 2V. Hence delta V is 0 because work done is what? P delta V, and P delta V is going to be what? 0. Hence the total work done in two successive processes is going to be, the first one was PV and the second one was 0. So if I am going to add both, they are going to be what? PV. And for isothermal expansion, work done is going to be what? So for isothermal expansion, the work done is nothing but PV ln of Vf by V initial. This will be equal to PV ln 2. Hence the required factor is going to be what? PV ln 2 upon PV. That is nothing but ln 2. So the correct option is option number C, that is ln 2. Let's move on to question number 2. Question number 2 states that two identical containers A and B having same volume of an ideal gas at the same temperature have masses of gas as Ma and Mb respectively, where 2Ma will be equal to 3Mb. Now the gas in each cylinder expands isothermally to double its volume. And if the change in pressure in A is delta P, we need to find the change in pressure in B. Now the given thing is what? The given thing is that 2Ma equals to 3Mb, right? That is 2 times Ma equals to 3 times Mb. So isothermal expansion to double the volume implies pressure is halved. For same gas, ideal gas equation suggests that pressure is directly proportional to mass. Now let the initial pressure be PA and PB respectively, right? Then we know that PB will be equal to P times A MB upon MA. And if I'm going to substitute the values, it's going to be 2 times PA upon 3. So delta PB will be equal to what? 2 by 3 delta PA, which is going to be nothing but 2 by 3 delta P. Hence, the answer is what? Option number C, that is 2 by 3 delta P. I hope you people have understood how to solve question number 2. So without further ado, let's see what question number 3 says. Question number 3 states that 1 mole of an ideal gas in initial state A undergoes what? A cyclic process. You can see here that this is a cyclic process. That is from A, it goes to B, then from B to C, from C to A. So it's basically A, B, C and A as it is shown here. Now its pressure at A is nothing but P naught. We need to choose the correct options from the following, that is these. Now as A undergoes a cyclic process, that is A to B, B to C and again from C to A, so delta U has to be 0. Thus the internal energy is constant in this process and the internal energy is same at what? Point A and point B. That is what I am saying, that delta U is nothing but delta U is 0. Now in the process from A to B, we know that work done is what? Work done is integral of P dV, correct? Now as we know that PV is nothing but PV is RT naught, which is equal to nothing but P naught V naught. So W will be equal to what? P naught V naught integral of dV by V from V naught to 4V naught. And when I'm going to solve this, my answer will be P naught V naught ln of 4, correct? Now as internal energy is proportional to temperature, so T is also constant in the cyclic process. That is, T is what? Constant. So temperature is what? Constant. Thus I can say that Tc is nothing but Tc is T naught, correct? And PCV naught will be equal to P naught V naught. That is, PC is nothing but PC is P naught. So option number A and option number B are the correct options. Let's move on to question number 4. So question number 4 states that which of the following equations does not correctly represent the first law of thermodynamics for the given processes involving an ideal gas. We need to assume the non-expansion work is 0. Now we know that adiabatic process, for adiabatic process, we know that Q is nothing but Q for adiabatic process is 0, correct? That is, delta U is nothing but W. And we know for a cyclic process, delta U is what? Delta U is 0, which implies that Q is negative of W. Similarly, we know that for isothermal process, delta U is nothing but it is equal to 0. That is, Q is going to be negative of W. And for isochoric process, work is 0. That means delta U equals to Q. So the first one was for adiabatic process. The second one is for your cyclic process. The third is for your isothermal process. And the fourth one is for your isochoric process. So the correct option according to these is going to be what? Option number C. That is, adiabatic processes delta U equals to negative of W. So that is going to be the correct option. Next, because basically we need to find out that which does not correctly represents, and we know that this is what? False. So let's move on to the last question. The last question states what? It states that a process will be spontaneous to all temperatures F. So we need to find out which of these options is the correct one. Now I know that delta G is nothing but it is equal to delta H minus T delta S, correct? Yes. Now for a reaction to be spontaneous process at all temperatures, I know that delta G is negative, correct? And if it's non-spontaneous, then it has to be positive. So but in this case, we want to find out the one which is spontaneous. So for spontaneous, I know that delta G has to be less than 0. And it is possible when delta H minus T delta S has to be less than 0, correct? Because if delta G is less than 0, then this is also less than 0. And this is only possible when delta H is less than 0 and delta S is what? Greater than 0. Because this is going to for sure make delta G less than 0. So according to this, the correct option is option number B. That is, delta H has to be less than 0 and delta S has to be greater than 0. So I hope you people have understood how to tackle the problems of thermodynamics. You can go to EduRev and attempt these tests to understand this chapter in depth. You can unlock all the logged videos, documents and tests for JEE with EduRev Infinity Plan and ace your exams at less than 80 rupees per month. Thank you.